Hello, hello, check, check, check. I have taken a leap of faith and finally trying to do a stream once again. I'm not sure why is this the normal internet pattern in this area, or whether I'm not sure why internet is getting cut quite often. So I think I'll try and do one more stream till it is 5 o'clock IST, and then wrap things off for the day. So today's main goal was, at some point of time or other, was to make the droplet move downwards, and we are currently facing this particular issue, right? That currently we have the observation get above color in fragment shader doesn't seem to be working. In get above color, if we use a displacement of 100, nothing happens, but 1000 seems to trigger some changes. Why am I passing texture chords and vertex chords again and again in draw? And texture changes may not be saved to be used in further iterations of on draw. So this is because uh, at every on draw we are doing some sort of giving things to the pipeline kind of thing, right? As in, we are providing the vertices, we are providing we are not providing vertices, but we are providing the you're not providing texture cards and vertex cards again and again in one draw. I don't think that is happening. That is being done on init. It is not being done further, but I am passing the variables again and again. As in that I agree, but I don't think I'm passing the texture cards and vertex cards. Or is it being, no, the texture buffer, vertex buffer, and the handle is being done on draw, right? Yeah, so this is kind of happening, I guess. So these are the questions that I have with me currently. So yeah, fine. uh, we'll have to work with it as well, but what I can do currently is go through the article. In the article, there is something called a frame buffer. So that is what I understood from the article. We were going through the article in the previous live stream when again things went south. It didn't go south, but it just disconnected. So that is what is happening currently. No, so we have to check the article once again. Yeah, the article, if you check, you can see that there is something called preparing the textures, right? The entire simulation state will be stored in a single 2D texture in GPU memory. The simulation state being stuff that is done after the uh, fragment loading, right? Each pixel of the texture represents one life cell. That is the game of life rules that he is saying. This texture will have internal format GLRGBA. That is, each pixel will have a red green. Okay, this texture is not drawn directly to screen. So how exactly these channels are used is mostly unimportant. It's a merely simulation data structure. This is because I'm using the OpenGL for general computation, and I'm calling this the front texture. So there is something called a front texture and a back texture that is being used in the program. A 4 multi-bit channel seems excessive, considering that all I need is a single bit. However, due to frame buffer completion rules, in order to draw onto this texture, it must be GLRGBA. So there is something called frame buffer, right? That is being used in the OpenGL pipeline. This is what is important, I guess. There are two textures involved. Okay. In the article, There are two textures involved. There is a frame buffer involved as well. Yeah. So these two things are what is apparent from reading the first paragraph. We'll move on reading the article. Uh, yeah. The entire simulation state will be stored in a single 2D texture in GPU memory. Each, so I'm calling the front texture. 4. Okay. In order to draw onto this texture, it must be GLRGB. I could pack more than one cell into one texture pixel, but acha, okay. The packing could have been better in their case, but they could not do that because it will anyway run once per pixel. So it doesn't matter. Yeah, okay. Because cells are updated in parallel, this can't be modified in place. It would overwrite important state. In order to do any real work, I need a second texture to store the update. So in our case also, in our case as well, we cannot we so the names of the front and back texture are swapped because cells are updated in parallel. The texture can't be modified in place. Yeah, in place it can't be modified. There is something called a back texture as well. And there is a swapping of this state that is happening. I think we'll check what is a frame buffer in OpenGL maybe. I think that's a good starting point. Frame buffer, OpenGL, Android. Yeah, this is some sort of a new thing that is happening. I don't know whether I have the energy to solve this today. Maybe we'll just work on the algorithm of um, water coming down and water spreading, right? We'll just try to go through the algorithm. Maybe I don't have the energy to solve the frame buffer thing today, since there is only like 40 to 45 minutes left. Let me check. Algorithm for moving down, I have actually mentioned above. What is algorithm for moving down? For moving down is pretty simple. You check whether the previous state was about previous current state. Algorithm for water droplets moving down. do control B, but anyway. Algorithm for water droplets moving down. If current state is water or empty, if above state is water, current state is water. This is what algorithm for moving down is. But now the after there is a uh, now we might have to mark certain cells as moving down and certain cells as not moving down. I don't know. I'm not sure here. So so what is the issue with this is this will keep on moving down irrespective of there is a collision or no collision happens, right? So that is one. So there is needs to be some sort of a mechanism to understand collision one and understand water that cannot move down, right? Uh, so direct collision for understanding, you can just say, as in with this algorithm, water won't move down below the with this algorithm, water won't move down below the so below the it won't move down below the collision point, because at the collision point, if you check, you will see that it has a cup present, right? But what will happen in case of water that is not going to move down, right? As in, suppose the in between water, right? The end water won't move down. The in between water, what will happen is uh, it uh, it will basically still move down, right? As in, so there needs to be some sort of way in which it can be understood that uh, a collision is happening. So suppose there is a structure, right? This is getting tricky, I guess. Uh, and it would have been easier if there was some sort of algorithm in case of spread, in case of this which this get executed, right? If that was the case, as in if the screen was being rendered from